Hi, my name is Greg Shapland. I'm a technology manager within Orica Digital, and I am the host of the Practical Data Analytics and Machine Learning short course.
My name is Eiman Amini, and I am leading the technical services at Orica Digital Solutions, and I am facilitating the practical data analytics and machine learning short course offered by us IMM. The major thing is we are looking to reduce the cost, and reducing the cost is not just just about reducing the dollar per ton. It's actually about reducing the resources that we are using. So the resources could be type of different energies like diesel and electricity that we talked about, and if we can optimize our operation, we can reduce those energies, and we can reduce our impact on our environment, and also we are using the same people, the same equipment for producing more material now. So basically, those equipment, those people also, are generating. All of us do. So reducing that per ton of material produced, I think, would have very, very direct impact on the environment and also on the economics of the operation. So, basically, these are the material produced in the mines, or the raw materials to what we are using every day, and that makes it more affordable for people as well. So we can see it in the pipeline or in the value chain of the material from the mine that becomes a useful tool in our hands. We reduce the emission and the cost for producing them.
Yeah, I think you're right. Mining plays a very important role in a large number of communities, and if we can make mining more sustainable through being more efficient, then there's a great outcome for many people.
There's no other way. We should look at the type of resources that we are dealing these days. They are low grade. And they are larger usually, but they are very low grade. The only way to be able to extract them economically is to be more efficient. So we need method, techniques, and models to look at different ways of processing material, mining and processing material, and find a way that is more efficient. So basically, the ModelNet is a software that allows people like me, like miners and metallurgists, to develop these predictive models. So we basically want the miners and metallurgists to focus on what they are doing best, understanding the production units, how they operate, and then leave some of the very heavy lifting tasks, like looking at different mathematical techniques and different data analytics methods to ModelNet to help them to develop those models. So I actually used ModelNet for several of my projects. I used the ModelNet to develop hybrid comminution models. So by hybrid, I mean using phenomenological or physical models and combine it with data-driven models in order to improve the predictability of the model. And also, I used it for development of flotation process models, looking at all of the phenomena involved in a flotation process. Let's say we have got hydrodynamical parameters that are involved in the process, as well as a chemical condition of the pulp. So we want to look at different parameters that are involved in the phenomena, and be able to predict what's happened when we change those parameters. One of my favorites, because it basically solved a problem problem that I was thinking about in the last maybe 10, 15 years, to be able to build a model in a very short period of time without interruption to the operation, without doing error and trial, and be able to develop a predictive model that help you to basically analyze different conditions and find the one that is best for your operation and can increase your efficiency. Again, I think that's the key.
So I think, firstly, there's been a shift in most industries in the last 5 to 8 years in terms of data analytics, where now we have what we'd call data specialists. That didn't exist 8 years ago. And so in the past, you'd have engineers that would go and get some data from a source system, do some analysis in Excel, develop some models, and then make some recommendations and decide to take action. What's really changed from then is that now a lot of the data is stored centrally. It is wrangled by data specialists who produce often reports or analysis, and those intermediaries are the ones that are preparing a lot of the analytics for consumption by engineers. What this course is about is saying, actually, as an engineer, your role is changing, that you don't have to spend the time to go and grab samples of data, that you're actually now needing to understand what is happening between the capture of that data and being produced or fed to them in the form of dashboards or reports. So their role is changing, and they have to understand that. They have to ask better questions of those people that are preparing these analysis, and then they have to recognize their role in helping people understand what is really happening there. I think everyone in the industry understands the quality of data issues that we often have. They understand that the physics and chemistry, where mining is a physical process. They understand those things, and these are particular aspects of the mining industry that needs to be combined with data skills to make sure that analytics is properly used in mining. So the practicality of what we're doing is not focusing on teaching people skills on programming in terms of using machine learning libraries. It's not necessarily even about manipulating data in some of these tools like Power BI. It's really about focusing them on asking the right questions and also guiding others to make sure that we get the right information and data, and it's analysed in the right way that we can build models that we're confident represent the physical phenomena that exists.
Greg, I would add to that as well by mentioning that there are some decisions that can be taken in an operation that are practical, meaning they are doable considering the time, resources, and the type of equipments that are available at an operation. So basically, looking at the data and communicating with the right people at the operation would allow you to make those practical decisions. For example, we cannot change equipment in a shift or a week, but we can consider expansions in a 2 years' time. So these sort of decisions can be can be analyzed, and based on the practicality of them, the different people from different background can make the decision which ones can be actually adding value to the operation. So those information collected from the data and the models help you to generate a set of data that can feed to your analysis and go through those practical solutions and find out which one of them can actually add value, and pick the one that adds value most and pursue that.
Yeah, I think just to round that off, we've talked about analytics for its own sake is not valuable. It is ultimately the decisions and outcomes that you derive from that data analytics and machine learning, and that's really the focus.